All right, so we're going to review for test 13. Test 13 is covering vertex form of quadratics and radicals. So let's take a look at number 1. The directions say if the quadratic is a perfect square trinomial, write the expression that describes the trinomial as a square. So number 1 says x squared minus 36x plus 324. So the first thing I want to do is check to see, is this a perfect square trinomial? Well, I'm going to take a look at that b value, negative 36. If I divide that by 2, what's negative 36 divided by 2? Negative 18. Well, that c value, remember c, if we square half of that b value, we should get c. So negative 18 squared is what? 324. So is number 1 a perfect square trinomial?
Yes.
Yes. So I can write this as a square. So I'm going to say x, well, we have plus or minus? Minus 18. Number 2 is similar. Number 2 says x squared plus 18x plus 81. So I'm going to take half of that b value, so half of 18 is 9. And 9 squared is 81. So is x squared plus 18x plus 81 a perfect square trinomial? It sure is. So we can write that as a square. So I'm going to say x plus or minus plus 9, because 9 is half of 18. Are there any questions on identifying perfect square trinomials? Number 1 and number 2. All right. Number 3. Number 3 says, what is the value of c that makes the polynomial a perfect square trinomial? So to do that, we're going to do what we did before to check, right? So we're going to take half of 52, sorry, negative 52. Negative 26. And then to find c, what do I need to do with that negative 26? Multiply it by itself. We're going to square it, right? So negative 26 times negative 26 is, well, is it going to be negative or positive? It's got to be positive, right? Because if we say a negative times a negative, we get a positive. And 26 times 26 is 676, right? So c equals 676. Yes, most definitely. Anytime I have parentheses and I'm using a calculator, I like to use, anytime I have a negative and I'm using a calculator, I like to use parentheses to make sure that negative stays with the number. Very good. Yes, because if you don't use the parentheses, what it's going to do is it's going to square the 26 and then say times negative 1. Because it's going to do the exponent before, because it thinks you're telling it to multiply by negative 1. It's doing what it thinks is PEMDAS. So we have to tell it that 26 is negative. Very good observation. Number 4. Number 4 says, write the following quadratic in vertex form. So I have f of x equals x squared plus 28x minus 15. So is this a perfect square trinomial? No, because half of 28 is 14, right? And 14 squared is not negative 15. So what we want to do is we want to make a perfect square trinomial so that we can write this in vertex form. So I'm going to say f of x equals x squared plus 28x plus some number. And what we're going to do is we're going to fill that in with what would make this a perfect square trinomial. Minus 15 minus that same number. Because if I add something, bless you, and subtract the same thing, those are inverses, so it's like we didn't do anything, right? So it's like we're adding 0. All right, so what number would make that first part a perfect square trinomial? Well, half of 28 is 14, right? And then 14 squared is 196. So I'm going to add 196 and subtract 196. So it's like we added 0. All right. So now I can say f of x equals, well, if this is a perfect square trinomial, I can rewrite this first part as a square, like we were doing in number 1 and 2, right? So this is going to be a square. I'm going to have x, will it be x plus or x minus? X plus, because my b value is positive, plus. And then half of 28 we found was 14, perfect. And then negative 15 minus 196, negative 211. And we're done with this step. This is in vertex form. Number 5. Number 5 says, what, that should say is, I apologize for my typo, the vertex,
What the
the vertex doesn't make sense. It should have said, bless you. It should have said, what is the vertex of the quadratic? I apologize. What happens when I don't read it 3 times? I just read it twice. All right, so I have f of x equals 7 times x plus 2 squared plus 13. Well, that looks like, I'm going to write the parent function here. F of x equals a times x minus h squared plus k. What part of that equation is my vertex? The h and the k, right? H, k. So what is the vertex of this quadratic? Negative 2 and 13. Why is it negative? Here this says plus 2. We have to change the sign. Remember, those x's do what?
Lie.
They lie. All of your x's lie. Number 6. Number 6 says, find the solutions to the quadratic algebraically. So I have the problem f of x equals x minus 5 squared minus 36. So the first thing I want to do, if I want to find the solutions, I'm looking for the zeros, right? So I want to know what is x when f of x is 0. So I'm going to say 0 equals x minus 5 squared minus 36. So what's the first thing I need to do to get x by itself? Add 36. We're going to do the inverse of minus 36 and add 36 to both sides. So I have 36 equals x minus 5 squared. I meant to write that in blue. All right. So now the next step to get x by itself, what do we need to do? To get the square root, because to get inside the parentheses, we have to address that squared first, right? So let's take the square root of both sides. So I'm going to take the square root of the right side, the square root of the left side. But remember, when we take the square root of a whole number, we're going to do, sorry, of a constant. I said whole number. When we take the square root of a constant, we're going to do plus and minus. So I'm going to have plus and minus. What's the square root of 36? 6. Equals. Well, when I take the square root of x minus 5 squared, what happens? It's just going to be x minus 5, because the square root and the squared are inverse operations, right? So they cancel. All right, I'm going to move this up just a little bit. All right, so now what's the next step to get x by itself? Add 5. So if I add 5 to both sides, now I have 5 plus and minus 6 equals x. So I have two options here for my 0, for my solution, right? So I have x equals 5 plus 6, and I have x equals 5 minus 6. What is 5 plus 6? 11. 5 minus 6? Beautiful, negative 1. So my solutions are x equals 11 and x equals negative 1. Perfect. Could I graph that and check if I was unsure? Most definitely. But I do want to see your work here, but then if you want to graph your answers to be sure, because especially if this were multiple choice, do you think that negative 11 and positive 1 would be an answer? I would do that. And if you saw that, would you maybe second guess your answer? Maybe a little bit. I know I would. You're welcome to graph and check your answers. All right, number 7. Number 7 says, write an equation of a quadratic in vertex form that has a vertex at 6, negative 8. So if I have a quadratic in vertex form, that means it looks like y equals a times x minus h squared plus k. So I'm going to write this as y equals, do I need an a value? No. Could I write an a value? Yes. I'm going to leave my a value out for now. I'm going to have x. So my h value is 6. So am I going to write plus 6 or minus 6? Plus or minus? I heard both. Well, what do we know about our x's? They lie. And here, if this says positive 6, we're going to write negative 6. Beautiful. See, our formula says minus h, and that h value is 6, so we use the same sign. All right? And then my k value is negative 8, so I'm going to say minus 8. Any value for a would work here. So if I put a value for a, that would work. Do y'all want to put a value for a? No? 1? Sure, I'll put a 1 just to say we have something there. Beautiful. All right, before we move on to the back, I want to stop and ask you, do you have any questions on the front? Does the front look familiar? Like the quiz last week a little bit? Yes? All right. Let me know if you change your mind because it looks like we will have a little time at the end. Okay? Think it over. All right, the back side is all about radicals and Pythagorean theorem, the things we were doing this week. So let's take a look at the back. We're going to start with number 8. Number 8 says the directions for 8, 9, 10, and 11 are all simplify. Number 32, sorry. Number 8 says the square root of 32. So to simplify that, I want to factor 32. What goes into 32? Ooh, 8 and 4. All right. What goes into 8? 4 and 2. And it's really interesting because first period chose the same 2 factors. So I'm going to pose a question to you. Should we factor those 4s or could we leave them? Why do I want to leave them? Because they're doubles, right? If I've got doubles, that's easy to factor out, right? So let's leave them and see what happens. So the square root of 32, that's going to be the square root of 4 times 4 times 2. I just rewrote my factors so that my like numbers were next to each other. I just rearranged a little bit. And I have a pair of 4s. So I could rewrite this as the square root of 4 squared times the square root of 2. Well, what is the square root of 4 squared? 4. Because 4 squared is 16, right? And the square root of 16 is 4. But remember also, I want to go back to this problem here. When we took the square root of x minus 5 squared, we said those were inverse operations. And that's why we were left with just that base, x minus 5. So when we have those inverse operations, the square root and squared, those cancel and we're left with just that base, 4. So I have 4. Square root of 2 doesn't simplify, so I leave square root of 2. That's your answer. Nine and 10, I formatted kind of funny, I apologize. So I want to write my work for 9 over here so that I have space for 10 also. So 9 says the square root of 225 r squared. So I'm going to factor that 225. What factors into 225? 15 times 15, right? 15 times 15 is 225.
We don't have to solve it.
No, because we have a pair, don't we? So let's set that up. So I've got the square root of 15 squared. So I've got my pairs here. Times r squared. So that's the square root of 15 squared times the square root of r squared. What happens here when I have the square root of 15 squared? That simplifies to be 15. And the square root of r squared is
59.
r. So my answer is 15r. I put number 9 up here so that I know that's my work for number 9. All right, I'm going to change my colors up a little bit so 10's easy to find. Number 10. I have the square root of 441 1. What goes into 441? 21 and what? Oh, and 21. We don't. Because what do we know about 21 and 21? If we've got two 21s, it's a pair. Very good teamwork. So I've got the square root of 21 times 21. So that's the square root of 21 squared. So that is 21 because the square root squared cancels and we're left with 21. Number 11. I have the square root of 300k cubed. So if I factor 300, what goes into 300? Ooh, 30 and 10, right? Are those the only two factors I could start with? No, I could have started with 3 and 100. I could have started with 50 and, what, 6? There's lots of places to start, right? I like 30 and 100. Kind of evens it out, right? Seems like kind of a middle point. All right, so what goes into 30?
6 and 5.
6 and 5?
Yes.
All right, let's do 6 and 5. I like it. All right. We could have done 10 and 3, yes. What goes into 6? 3 and 2. And then I still have this 10 up here. What goes into 10? 5 and 2. All right, and then I still have my k cubed here. And if I'm doing a square root, I want pairs. I want squares, right? Is there a k squared in k cubed? K times k squared gives me k cubed, so I do have a square in there. So I can rewrite this as, see, I have 2 2's, so 2 times 2 times 3 times 5 times 5 times k squared. All right, I want to identify my pairs. I've got a pair of 2's. I have a pair of 5's. And I have my k squared. So I can rewrite this as the square root of 2 squared times the square root of 5 squared times the square root of k squared times, and then everything that's left over. I have 3 and k, so the square root of 3k. So the square root of 2 squared is 2. The square root of 5 squared is 5. And the square root of k squared is k. And then 3k, the square root of 3k does not simplify. So we have the square root of 3k. So 2 times 5 times k is 10k, square root of 3k. All right. 12 and 13, we may need to do some of that simplifying. We're going to use Pythagorean theorem and then simplify. Number 12. It says find the missing leg of each triangle. Here both of my triangles in 12 and 13 are right triangles, so I know I can use the Pythagorean theorem. So I have a squared plus b squared equals c squared. So what is A? Sure, I could use 6. 6 squared plus B is 8 squared equals C squared, because we don't know what C is. All right. So I can simplify. I can combine like terms here on the left side. So I have 6 squared is 36 plus 8 squared is 64 equals C squared. 36 plus 64 is 100. And what do I need to do to get C by itself? Because I know that C squared is 100. Square root. So I'm going to take the square root of the left side, square root of the right side. And I don't need to do plus and minus because can I have a negative side length? No, you can't have a negative side length. If you run backwards, are you running a negative distance or are you just running backwards? Just running backwards. So we don't need our negative side length. So I'm just going to take the positive square root. So the square root of 100, I know that 100 is a perfect square, so C is 10. Question? It is. It is negative yards, but did you still run that distance? Ooh, okay, so that,
Like on the, like, 'cause if you run a total amount of yards forward and all that, it adds up, and if you run it back and use yards,
then it subtracts it. So in football, if you run back, you can have a negative distance in football. All right, so that's an exception. So in the game of football, you can run backwards. I'm repeating so they can hear in the video your exception. I like it. You can run backwards and lose yards, right? But if you added up the total amount that you ran that day, it would still be a distance, right? Not in the rules of football, just in general, right? So it depends on how you're looking at it, as if you have a negative distance. Very good exception. I like it. Thank you for that, sir. All right, number 13. We have another right triangle, so I can use Pythagorean theorem again. So I've got a squared plus b squared equals c squared. So my side lengths, do we know a? No, that's what we're going to find. So I have a squared plus b is 9 squared equals 17 squared. So then I have a squared plus 9 squared is 81 equals 17 squared is 259? 289. Sorry, why did I write a 5? I always have trouble with 17 squared. I don't know why. I can never remember. All right, so then to find a, I'm going to do the inverse of add 81 and subtract 81. Beautiful. So I get a squared equals 208. Very good. Oh. And then to get a, we're going to take the square root of both sides. Is 208 a perfect square? No, so we're going to factor it. So 208 factors, what goes into 208? How much? 104 and 2. All right, and what goes into 104? 52 and 2. And what goes into 52? 26 and 2. What goes into 26? 13 and 2. And then 13 is prime, right? All right, so then I can write the square root of 1, 2, 3, 4 2's. 1, 2, 3. So 2 times 2 times 2 times 2 times 13. All right. So this is the square root. I've got a pair of 2's and a pair of 2's. So the square root of 2 squared times the square root of 2 squared. And then 13 is all by its lonesome. So the square root of 13 won't simplify. So what is the square root of 2 squared? 2 times, we have another one, 2 times the square root of 13. So then I can combine like terms for my last step. 2 times 2 is 4. Square root of 13 is that side A. All right. The last two problems both use this word problem here. So 14 and 15 both use this word problem. It's a one-sentence word problem. That's it, one sentence. That's it. All ready? All right. So my word problem says 2 joggers run 30 miles north and then 40 miles east. I see how ridiculous that is. That's a long way to run. So we're going to assume that they're like super marathon runners. They like to run a lot. All right, so number 14 says, write an equation that describes the shortest distance they must travel to return to their starting point. Well, what would really help here? What would help me write my equation? I'll draw it out, right? A picture. Let's draw a picture. So my 2 joggers, they start out, and they run 30 miles north, so I'm going to draw an arrow north. I'm going to put 30 miles. And then they turn and go 40 miles east. So if this is their starting point, and this is their finishing point, for now, right? They wanted to go back to the starting line, and the shortest distance, would they go back west and then south? Or would they cut across? Cut across, right? So that's going to create a right triangle, and we need to know what's that hypotenuse, right? So I could use what? Pythagorean theorem. I'm going to say a squared plus b squared equals c squared. So what's my a value? 30. What's my b value? 40. So 30 squared plus 40 squared equals c squared. So this is the formula I need to use to find that c value. All right. Number 15 says, what is the shortest distance to the nearest tenth of a mile that the joggers travel to return to their starting point? So then we're going to use that formula from number 14 to solve. So I've got 30 squared plus 40 squared equals c squared. So 30 squared is 900 plus 40 squared is 1,600 equals c squared. So I could combine 900 plus 1,600. I get 2,500.
Good morning,
What up?
Catherine.